I like to think of our forensic reports as sort of an API for our expertise. So if you're familiar with what an API is, an API is just an interface that allows systems or programmers to use other abstracted, complicated pieces of code. And in this case, what we're doing is we are taking our expertise as a forensic analyst or digital forensics expert, and we are creating an API that serves as an interface for our expertise. So what that means is you have, let's say a prosecutor comes to you, they say, here's a computer, I want you to do some analysis. They don't necessarily care how you did the analysis. They don't necessarily care, what you did in the 6 hours that you spent looking at the computer data. They want to give you a computer, and what they want back is a result that they can understand, right? Here's a computer. I need to know if bad things happened on this. And what they want is a report that tells them whether those bad things happen or not. They don't necessarily care about the specifics of why or the specifics of how it happened. They don't necessarily care about how you figured out it happened, at least not at this point, right? Eventually that stuff will become important, but at the point of reporting and forensic reporting, what they're looking for is simply they want to give you something, and what they want back is a set of results that they can take action on.
So what's cool about this is I have the messages here that are in JSON format, has just a basic chat session, message date, type, sender name, text, message, and service. And it's just a JSON file that if you're familiar with JSON, it's just an array of objects that have the message content. So in Cursor here, I'm going to, in the chat box, I'm going to reference this data. I'm just giving it a prompt here, and it's going to look at my messages file here, which are fake messages, by the way, they're not real. And then I'm going to run this, and we're just going to see what kind of output it gives. So this is what the report looks like that it generated. You can tell, like I told it, hey, make it look like or similar to an iOS messages app. And that's what it's giving you. And it's giving you some time information. And you can also iterate on this if you're using something like Cursor. And you can also do this inside of Claude or inside of ChatGPT. But the purpose of this, it basically, you can iterate on it. So like here, maybe you want the actual timestamps to be on every single bubble message. You can do that. You can tell it, hey, can you now edit this to add the timestamp to each bubble? So let's give that a shot and see what we get. So here's an example of the new report. So now what we have is we have these timestamps at the bottom of each message bubble, so we can more easily see exactly when the message was sent. And this is a demonstration of just one example that this has nothing to do with forensic analysis. This is just simply about if you're writing a report and you really want to make your point come across, if you want to deliver good results in court, if you're helping the prosecutor prepare for things, or you're helping the attorney that hired you prepare for things, using AI in these ways to help the impact that you're having on the case a lot better and a lot stronger. And taking AI and using it to your advantage is another tool set that you have to make you an even better expert, a more attractive expert, and just helping the attorney navigate these technology issues in ways that they just may not be aware of, because the attorneys may be able to use ChatGPT, but they will not be able to do this thing I just demonstrated here, where you actually use a code editor that has a coding agent built in, and you're using that coding agent to basically build these custom systems for displaying information that you can basically control exactly how the information is displayed, exactly what information is displayed. And if you think about the tool sets you have now, you're basically just reliant on whatever vendor tools are giving you in terms of export options. And those may be fine in a lot of cases, but maybe you want something more specific or more unique, or something that helps you get the point across better that you're trying to explain.
For the digital forensics side of things, we are very similar in the middle. And then on the other sides, obviously, there's the sort of pitfalls and challenges. So for prosecution, again, needs search warrants, needs court orders. Maybe you're getting consent some of the times. But then you're also sometimes limited by the scope of your warrant. So when you actually get that data off the phone, what are you even allowed to search for? What are you allowed to look for? On our side of things, we don't have that challenge of obtaining data from the phone because the client is providing a passcode to us. So obviously, when you bring that to your Gray Key or your Celebrate, you don't have to go through that brute forcing method to try to figure it out, or using things outside of forensics, like a password written down on a sticky note somewhere to try to get into a phone. So they provide us the phone. In that sense, it's very easy because we plug it in and we're ready to go. We don't need to worry about anything else that's occurring in the background there. So what the other part of that is that we have a privacy concern on the defense side. So a search warrant, there's again, no unreasonable search of the phone. But once that search warrant is enacted and the data is extracted, there's no privacy there, right? But the defense side, we have want to be cognizant of what the client wants to show us and what they don't want to show us. Just as a very easy example, the case could just have messages that are relevant. So we don't need to go in and do a full file system extraction all the time to get those. But as practitioners of digital forensics, we know that sometimes a full file system will help us show things that maybe the messages don't. So for instance, if something was deleted, we wouldn't necessarily see something like a biome or a knowledge C database able to show us maybe a notification of a deleted message in the database. So when we can, we try to get as much data as possible to support the client, but also trying to be cognizant of their privacy in their case as well.
Okay, so typically the way these HTTP methods work is if we make a GET request to this endpoint, Monolith is going to return. This is basically telling the Monolith server, hey, get me a list of evidence items. And so if you use the GET method, you're going to get to this endpoint, Monolith is going to send you a list of evidence items in your Monolith database. Post usually means you're going to post some data, meaning you're going to send some data to the server and you want the server to create a record for you. So with post, that means we're going to, if we use post with this evidence endpoint, same endpoint, just a different HTTP method, it's now going to expect you to send some data to the server so that the Monolith server can create an evidence record for you. And then we also have put and patch. Put and patch usually relate to some kind of update. So we typically use patch, and patch is where you would update, you might want to update details of an evidence item that already exists. So you might use a patch or put endpoint. These are usually interchangeable. They mean slightly different things, but they're more or less used interchangeably with each other. And this usually represents some kind of update that you're making to a record. And then you also have the delete method, which is an HTTP method, which is typically used to say, hey, I'm using this endpoint to delete a resource or delete a record. And the reason these are used is because it allows us to use this exact same endpoint here. We use this exact same API endpoint, and all we have to do is change the method that we're using to dictate the different actions that we're trying to take on this particular resource. So the way to think about it is this API endpoint is being used to identify what data we want to do operations on. And then these methods identify the type of operation we want to conduct on this API. And that's what RESTful, that's when I say RESTful, that's what we're referring to is this sort of orientation here, this pattern of using get, post, put, patch, delete with a singular resource identified endpoint. That is what RESTful APIs are usually mean. Okay, so what you're seeing here is that I know the text is going to be really, really tiny, but don't worry about that. That's not really important. I've got a text message database from iOS loaded into DV browser. This is actually from my personal phone, but I've gone in and cleared out all of the I've replaced all the message data with stuff that are not real messages, so I don't leak any messages I have or anything like that. But basically what we want to do is if we want AI to help us with this, one of the things I'm going to do is I want to provide the AI context of the database that we're working with. And one of the ways I can do that is I can just export and go to File here, DV Browser, select the export option, and then select Database to SQL File. And what this is going to let me do is under Options here, I've got all the tables selected already. Under Options, instead of export everything, I just want to export the schema only. And what this is going to do, it's going to export a SQL file that basically has a plain text description of the structure of this database. So I'll go ahead and save this. Here, I saved it here, so I'll open this up, and what you'll see now is This is basically what this is basically a bunch of SQL queries that will create tables. But what it's doing is it's basically outputting the structure of all these tables that make up this database in plain text. Okay. So now I have this nice plain text file that describes exactly what the database looks like. And what I can do is I can switch to something like ChatGPT. Okay, so I have ChatGPT here, and what I'm going to do is I'm going to upload a copy of this SQL file. So I'm giving it a pretty simple prompt, and what I want it to do is look at this file and then basically help me write a query that's going to export the type of data that I'm looking for. So we now have this query that I'm going to copy. I'll switch back over to my DB browser. And then I've copied that query. I'm going to head over to my execute SQL. And then I'm going to paste in that query and I'm going to run it. And let's see if it actually works. And it did.
The next one we have uses some metadata for videos and another phone extraction. So this one was interesting because somebody that our client was living with had accused him of assaulting them in their home. The reason that it's a big deal in New York is that this was actually a elderly person. So in New York, even like a simple assault, if it's against an elderly person, is immediately upgraded to a felony. So it immediately became a pretty serious case. So they had brought us in two damaged devices. And unfortunately, they didn't have a cloud backup. They didn't have anything like that. You know, it was a story of like, oh, like the videos on my phone, they're gonna show I didn't do it. I was the one that was actual victim. So I do a lot of repair personally. I really like doing phone repair. So in this case, we actually just did what I call a zombie phone, which is essentially we took a working good model of this same exact model and we just take the motherboard out. This was an Android. You can't do this with iPhones typically, but we were able to take the Android's motherboard out, place it in a good body that had not changing any of the data because all the data is on the chip. And then able to put it in with a working power button. I mean, the phones were completely destroyed. The screen didn't turn on. The USB port didn't work. Nothing worked at all. So we did that for both phones. We, took the logic board swap. So we just took those, threw them in, and then we had working phones. And it sounds intimidating, but realistically, it's very simple. It's just kind of playing with screws and making sure you get everything, and you don't break anything when you take them apart. But yeah, we were able to get those working. We got a celebrate extraction for them. And then the videos metadata showed the time and date of the actual incident that the person was accusing of. And it showed that the person, this elderly person, had actually been throwing stuff at our client instead of the other way around. And they actually got hurt within the course of that. So kind of an interesting one there. I like that one because we did some phone repair for it as well. So that was a fun aspect to that one.
Validate your findings, not your tools. So what that means is that validating your software and your tools can be a fool's errand because these things change all the time. And you might validate version 1 today, and then they release patch 1.0.1 tomorrow, and you have no idea what they changed in that patch. And there's no sense in like revalidating the whole tool set. And these tools have hundreds and hundreds of features in them. So it's just not realistic to validate these, but it is realistic to validate your findings. So if you're looking at a data set and you have a significant finding from that data set, a piece of evidence or a series of artifacts or whatever that you're using to walk in a court or say somebody did something wrong, go through some of these things that I've talked about, go through these steps and these processes to validate those records, those artifacts that you're talking about, so that it's not just the tool that showed you this. So you don't walk in a court and say, yeah, forensic tool ABC showed me this. That's how I know the user did it. No, you walk in a court and you can say, yeah, this record is stored in a SQLite database that's managed by this application. That database maintains records of activity such as XYZ thing. And you could say, I examined that database file myself and found these records and found that these records match up with this timeline of events or whatever. And now that's what leads me to believe this person or this leads the investigators to believe this person was responsible for something.